Good day, everyone. This is my CIT 260 final presentation for my final grade after creating a game called Lost While Hunting for my class. First off, we'll be looking at static and non-static variables. A static class variable is reserved in the Java program memory. Anything that is saved to it will stay in memory and cannot be referenced at any time. A non-static variable is stored within class-defined objects, and they can be referenced from those objects, but the object must be within the scope of the game. Unlike static, which is always in scope, we notice that when saving our object to a file, no static variable would save. An object can only save a non-static variable. Here are two examples. So here we have a private static string, a couple of them, that is called item1 to item3. These variables are stored in memory, and we can actually access them from items.setItem1 by just simply using the class name. Otherwise, if we look at the top, we'll see that we actually have more private variables. These are non-static, and we control them from the locations control by calling or creating an item object. We then use these objects to call the referenced functions, and these reference functions can actually access these variables, and these variables will only be accessible within the object. Arrays, array lists, and enums. We now look at arrays and array lists and enums. So in this example, we use an array when we had similar items and knew the exact amount of items we were going to use. And the fact we could read and write to it, it was dynamic and could be accessed and updated on the fly. We use an array list when we wanted to store objects of an array. And within these objects, we could actually have different names, and the premise would we could add more items to our game at any time. An array list is dynamic and extensible, so it can be updated and extended on the fly. An array is, however, also dynamic, but it's not extendable. So this one is easier to use by using the add items.array.add, and this add function will allow you to continuously add to this particular array. We use an enum type whenever there are static things that we don't want to change at any time at all. So this works like a static variable, but it's actually a static class. For loops to access an array. We'll switch back to NetBeans to look at this one. In the questions and scene control, we needed to check for questions and scenes. So these two functions use an identical for each loop, and this particular loop checks every single item in an array one by one, which was perfect to check if the location was visited or not. If the location was not visited, it returns a scene or a question based on the need. Another example will be shown during the character stream section. How do we throw and propagate errors? To catch errors, it's best to start with a class that you specify. And here we can see our item and control exception class. Note that this class extends exception class, and we define a customized message. Note that this class is also your own class, and you can use it at any time. And this allows you to basically catch and throw errors at any time. Item control class will check for a null statement in this particular area. And when it checks for the null statement, it will actually throw an error that is customized within your item control exception. I will define a null statement here and run this program. All right, let's try to do that again and get an actual right option. Here you see the error. It comes back with a customized error that says error, item error, something went wrong in the inventory. All right, let's stop the program and remove this comment. That is how we basically catch an error. And the function actually throws the item control exception. Byte stream versus character stream. A byte stream will access a file byte by byte, and it basically uses an 8-bit input or output methodology. It is suitable for any type of file, but not appropriate for text files. In our case, we wanted to use a Unicode method. And that Unicode method would actually use a UTF-8 formatting. So within this section, we actually created a printer writer out equals null. And then within our try and catch, we use a out equals new print writer. Within the print writer, we define a new output stream writer. And within the output stream writer, we did a new buffered output stream. Then within the output stream, we did a new file output stream with a file path, and this is coupled with the UTF-8 in the buffered output stream. This allows any file path that comes from the string, which is defined in save items, to come into this file path, and it will automatically become a UTF-8 file. And it would print like this. And it will become really nice and neat. That is why we basically use a character stream. I will now demonstrate how the game works and functions in a real-world scenario with all this technology that is added to it. So let's save and then run. So first thing we do is put in our name. We start a new game, and we could actually use that. We can actually look at the help, because the help is fully functional. We could save the game even now, or we could continue a game that was actually created. So let's start a new game. So select a character. What we can do is look at the map, and the map will clearly show that we have visited no locations. So we move to a new location. Now this is a chance-based system, so if I press yes or no, it might be at a certain percentage that we will succeed or fail. So whenever you're successful, you get items. So I just got a map and an extra life. So we can actually look into the view inventory, and we'll see that we have a map and an extra life. And we could actually print out an inventory to a file, or sort the inventory alphabetically, or even sort the inventory by quantity. We can show how that works. And there you see that it's actually sorted by quantity. And we could actually sort it alphabetically as well. There you see it comes from in alphabetical order. All right, so let's go back. We move to another new location. We press 3 to fight. We won that fight, and we got another item. So we can actually look at the view map, and we'll see that we have visited 2 locations. Now this will actually persist all the way to the end, but we will move a little bit further until we get to a major location. These are minor locations. We're traversing through the map, and as you fail, you'll see that you actually get injured. We are now in a critical condition. If you continue, you'll basically die. But if you press move again, if you have a life, you can actually enter yes to heal. Whenever you're healed, it says that you're revived by the power of the Lord, and you're healthy again. So the best thing to do is actually go to E and equip some items. So we'll put on the bullet. This will give us a better chance to move through the map. We go to fight. We're still not successful. It seems like the game is very hard today. Now the player is dead again. So let's heal up the player again. Let's try to flight this time. All right, we got through. Move to another location. Now this is where a major location comes up. So when a major scene is loaded, you'll get different options. So it asks, you found a cool stream, it looks refreshing and clean. Will you drink? Will you trust the scenario suggested? You can actually choose Y for yes or N for no. A good choice, but you get nothing. No risk, no reward. And the game continues on this path. And it will get to the end game. Once it gets to the end game, you will be able to save the game by simply entering the file. And now your game is saved. We could quit the game, run the game again, continue, and if we go to view map, you'll see that the game continues. And this is a demonstration of how our final project works. I thank you for listening, and thank you for viewing, and hope you enjoy the rest of your day. Goodbye.